In this lecture, we will discuss about discrete uniform distribution. So there are two distribution related to uniform, which is a discrete as well as continuous distribution. So first we start with discrete uniform distribution. Discrete uniform distribution. This is also known as the rectangular distribution. So we can write down as also called the rectangular distribution. A rectangular distribution. So we define this discrete uniform distribution as, so let x be a discrete random variable. Let x be a discrete random variable. Discrete random variable. Discrete random variable means containing value 1, 2, 3. Discrete random variable have the discrete uniform distribution. Discrete uniform distribution with the probability mass function. In short, we write down as PMF. Probability of x is equal to x successes, which can be represented as 1 upon b minus a plus 1, where x, random variable x, lie between a to b and 0 otherwise. So we have interval which is ab. So now how to explain this on paper? So represent it graphically. So this is our random variable x. Here we write down the probability of x, px. So probability of x, which is defined as 1 upon b minus a plus 1. So we take the point which is b minus a plus 1 is here. Now this is the origin here. So we take the interval which is a to b. So we start the interval from a to b, and we take the intermediate values as a1, a2, a3, and so on. Then we can take as an into b, or an minus 1 into b. So an minus 1 into b. So now when we draw the line which is constant parallel to y-axis, so these line or the straight line, so behave as the uniformly. So behave as a uniformly, and when we are going to calculate for any particular interval, so this makes us a rectangular. Okay, so suppose we are talking about a to b. So a to b, so here is a. So here is a, and now this is b. So when we bound this uh, from a to b, so when we join a to b this to this side, so this a to b makes us a rectangle. So this makes us a rectangle. So that's why we called this as a rectangular distribution. Okay, when we take the small intervals strips, so all makes the rectangles. So this is the one definition. Another definition we can take as another definition. So a random variable x is said to have a discrete uniform distribution. Discrete uniform distribution over the range 1 to n if its probability mass function can be expressed as, so probability P of X successes can be expressed as 1 upon n. So here the value of X which lie between 1 to n, because we have the closed interval from 1 to n and second is 0 otherwise. So 1 upon n, so this is also a constant. So PMF is the constant. That's why it makes us a rectangle form. So here we have a one parameter, that parameter is n. So here n is known as the parameter for uniform distribution. And this n lies all set of positive integers, all set of positive integers. Now we take one example related to that. So for example, we roll a dice, we roll a dice. So then what is our random variable? So random variable will be getting 1, 2, 3, 4, 5, and 6. So these are our random variables, and the what is the corresponding probabilities? So for getting 1, 2, 3. So when we are going to calculate the probability of getting 1, which is 1 by 6, probability of getting 2, which is also 1 by 6, probability of getting 3, which is also 1 by 6, probability of getting 4, which is also 1 by 6, probability of getting 5, also 1 by 6, or probability of getting 6 is also 1 by 6. So this is purely constant when we see that. So that means this can be represented as probability of xi, I equal to 1 to 6. So will gives us equal to 1 by 6. So this is probability mass function for uniform distribution, I mean discrete uniform distribution. So that is 1 upon n. So here we know that this is 1 upon n is purely constant, which is the integer. So positive integer. So this 1 upon 6. So you can draw this on the paper that we graph. So similar graph we can draw here also. So that means we take the axis. So this is our random variable x. Here is px. So probability of each random variables are same 1 by 6. Now we can consider as 1, 2, 3, 4, 5, and 6. So all getting, and we draw for 1, 2, 3, 4, 5, and 6. So makes a uniform. Similarly, you can take for the tossing of a coin. So second example, for understanding this uniform distribution, so we can take the example 2. So tossing a coin. So when we are going to toss, so there are two possible outcomes. So outcome we have a head and tail. So what is the probability of getting a head, which is equal to 1 by 2? What is the probability of getting a tail is also 1 by 2. So then on the basis of these two, what are the random variables? So random variables x we consider as 0 or 1. That means for getting a head or getting a head or a tail or tail, sorry. So getting a head or getting a tail. So tail, so that means getting a head means we get 1, not getting a head means 0. So getting a tail, random variable is 0 or 1. So 0 or 1. So when we define the probability P of X, so this will be 1 by 2. So this will be 1 by 2. So here we have a X. Now this Px, so probability of getting head or not getting head are same. So that means when we consider getting a head or not getting a head, so both are the same. So head or tail, so both having same. So that means this is behave as a discrete uniform distribution. Now, after understanding the uniform distribution, we move to the mean and variance. So how to calculate the mean and variance of this distribution? So now calculate the mean and variance of discrete uniform distribution. Discrete uniform distribution. So we are going to calculate the mean and variance of discrete uniform distribution. So for calculating mean means mu, which is expectation of x. So how to calculate the expectation of x? So for discrete distributions, we have a summation of I equal to 1 to n or xi into pi. So xi into pi. So now what is xi, random variables? So random variables you can consider as the natural numbers. So we take n equal to positive integers, excluding, okay, negative integers or zero. So now this x with a random variable we write for 1 to n. So that basically we say that the natural numbers. So x having value 1, 2, 3, and so on. That means n, because we fix the interval 1 to n. So when we fix the interval 1 to n, so you can make a distribution. So we can write down this as x having value 1, 2, 3, 4, and so on to n. Now what is the corresponding probability? So which is 1 upon n, 1 upon n. Because this is fixed, because this is purely constant. Okay. So the probability of each random variable remains same. Now, so when we are writing xipi, so xipi means, so these are our xi's, x1, x2, x3, x4, and xn. Or these are the pi's, so means p1, p2, p3, p4, and pn. So when we open this summation, so we write down as x1 p1 plus x2 p2 plus x3 p3 plus and so on xn into pn. So this can be written x1 means 1. 1 into p1, 1 upon n, plus 2, 2 into 1 upon n, plus 3 into 1 upon n, plus next term will be 1, 4 into 1 upon n, plus uh, n into 1 upon n. So here we can take 1 upon n as common. So we write down as 1 plus 2 plus 3 plus 4 plus n. So this can be written as 1 upon n, or what is the sum of n natural numbers? So we know the formula. Sum of n natural numbers is n into n plus 1 upon 2. So this is the sum of n natural numbers. N to n cancelled. So this gives us n plus 1 upon 2. So this is the mean of uniform distribution. Now we obtained the variance. So similarly, we obtain the variance of uniform distribution. So first we obtain the expectation of x square. So this expectation of x square we write on x I square into pi. So this can be written as Here we write down I equal to 1 to n. So this means x1 square into p1 plus x2 square into p2 plus x3 square into p3 plus and so on plus xn square into tn. So we do the square of random variables. 1 square is 1 into 1 upon n. 2 square equal to 4, or we can write down as 2 square simply. So we write down as 2 square. So 1 square, 2 square into 1 upon n plus 3 square into 1 upon n plus 4 square into 1 upon n plus and so on plus n square into 1 upon n. So here we take 1 upon n as common. So this can be written 1 square plus 2 square plus 3 square plus 4 square plus n square. So we also know the formula, sum of squares. So what is the formula? So the formula is 1 upon n into n 2n plus n plus 1 2n plus 1. So we write down n plus 1 2n plus 1. So this is n into n plus 1 2n plus 1 upon 6. So n to n cancelled. So this gives us n plus 1 into 2n plus 1 upon 6. So now variance. So we calculate the variance. So variance equal to sigma square. Sigma square, we have the formula expectation of x square minus expectation of x to the whole square. So what is expectation of x square? This is n plus 1 and 2n plus 1 upon 6 minus n plus 1 upon 2 to the whole square. This is the expectation of x. So now we simplify this. So when we simplify this, so this can be written as n plus 1 2n plus 1 upon 6 minus n plus 1 to the whole square upon 4. So we take 12 as LCM. So 6 to the 12. So 2 into n plus 1 2n plus 1 minus 4 3 are so 3 into n plus 1 to the whole square. So this we simplify, we take as 2 we take n plus 1 as common. So here we take n plus 1 as common in numerator. So this can be written as 2 to the 4, 2 to the 4n, 4n plus 2 minus. So n plus 1 when we take as common, so this can be 3n minus 3. 3n minus 3 upon 12. Okay, so we simplify this to n plus 1 into 4n minus 3n means n of n minus 1 upon 12. So this gives us n square minus 1, a plus b, a minus b, a square minus b square. So this is our variance. So this is our variance for discrete uniform distribution. When we calculate the standard deviation, so standard deviation of square root of variance. So square root of variance, this equal to square root of n square minus 12. So when we calculate the standard deviation of n natural numbers, we can calculate by using this.